Air prep? We don't need no stupid air prep. We've heard that one a lot. Coming up, 5 common blasting headaches that stupid air prep can make go away. Welcome to this week's Primed Insight. Ladies and gentlemen, the air prep. You either love it, distrust it, or have no idea what this thing does. But odds are, if you've been blasting a while, you'll have felt the pains of not having this equipment on your job site. First, an air prep simply cools and dries the hot, moist air coming from your compressor. On planet Earth, there exists no atmospheric condition as 0% humidity. All air contains some degree of moisture. As corrosion control experts, your end goal, both during and after the project, is to prevent moisture from making contact with the steel surface. At least minimize this to a degree you are able. An air prep moisture removal system maximizes the odds of you accomplishing this goal. Here are those 5 common headaches in air prep remedies. These are common problems found on basically every job site we visit that isn't using an air prep. The first 3 problems all deal with moist abrasive. Just like sand in an hourglass, the abrasive falls from the pot through the metering valve and into the blast stream by gravity. Let's imagine the hot, moist, compressed air travels directly from the compressor into the blast pot, where this moisture is absorbed into the abrasive, in essence, dampening the abrasive. When the abrasive gets moist, it clumps and it doesn't fall naturally from the pot through the metering valve. This is an extremely common problem. Almost every blaster has experienced this situation. Not enough abrasive enters the blast stream and blasting either suffers or halts. Now that may seem like the problem, but that's not even one of the 3 problems we're exposing. The 3 problems occur because of the solution the blasters take to increase the abrasive flow. They choke the pot. To get the abrasive to fall into the airstream, they simply lessen the pressure in the pusher line, which then creates an imbalanced positive pressure in the pot. Aha! They think the pot's pressure is greater and will force that abrasive into the blast stream. And that does work. However, it works at the expense of 3 very costly side effects. You use more abrasive, actually waste it, which costs money, causes more downtime to refill the pots, and because you use more abrasive, it costs more to clean up and dispose. Even if you aren't constantly choking the pot, your operators are compensating for moisture by opening the abrasive valve more than they would need to if you had an air prep. We have seen up to 15% abrasive savings with an air dryer in dry desert climates. The positive pressure of the pot now forces that abrasive through your metering valve, which causes premature wear, costing you either downtime, increased maintenance and repair, or in time, both. And finally, by choking the pot and reducing the pusher line pressure, you are now blasting with reduced pressure. And for every 1 psi of pressure loss, you can expect a 1.5% efficiency loss. A 10 psi reduction simply to force the damp abrasive into the blast stream equals 15% inefficiency for the remaining time that lower pressure stays intact. If you don't think this is happening on your job site, we invite you to inspect for yourself. Globally, we visit thousands of job sites each year, and this situation is rampant across every country we're in. And that's just 3 problems. Problem number 4 is you're smashing moist abrasive into the substrate when your end goal was to reduce moisture coming into contact with the surface. Without an air prep, you just increase the probability of flash rust. And a 5th problem, which seems so remote, most don't even consider it, is when you're blasting in very cold temperatures. The moisture traveling through the compressed air finds its way not only to the steel surface, but also inside your lines, hoses, and valves. Even your pneumatic deadman controls. When you shut down for the day, that moisture stays inside, potentially freezing overnight and causing complications the next morning on startup. You reduce or eliminate all of these problems by minimizing the moisture in the compressed air. And the best way to do that is by using an air prep. But I use a moisture separator. My compressor has an inbuilt aftercooler. I work in mild climates. I've used an air prep and it drops my pressure. Let's tackle these objections one by one. A moisture separator only removes the incoming heavy moisture. It does nothing for moisture at the vapor level. Also, the diameter of these cylinders don't really facilitate much expansion to shake out the moisture. These are better than nothing, but kind of like putting a band-aid on a bullet hole. Inbuilt compressor aftercoolers. First, we have found they can lower your pressure up to 15 psi. That's a 22% drop in efficiency. Our air preps typically have a 3 psi drop when the air expands in the vessel to shake out the water. Second, we decided to test the efficacy of inbuilt aftercooler by attaching it to one of our air preps. We wanted to see if the air prep could catch any remaining water that escaped the compressor.
G'day guys, we've just done a verti drive demonstration with an MP blast, all hooked up through a 1200 CFM air prep and a 1050, 1050 CFM Atlas Copco compressor. You notice it's got two outlets. One's a non-aftercooled. We are hooked up to the aftercooled outlet. This tip is to show you how much water comes out of a air prep, even using an aftercooled compressor, after roughly half an hour's blasting. Let's see how much comes out. That, folks, would have gone straight through the system onto your surface. That's a testament to the air preps working in Australian dry climate conditions. Compressed air moisture removal system. Even takes moisture out of after-cooled compressors.
This video was shot on a sunny day in a mild humidity climate. So not only does it address the inbuilt aftercooler objection, it helps cover the mild climate defense as well. That leaves the final objection. An air prep drops my pressure. This is true. However, an inbuilt aftercooler can drop your pressure by 15 psi. A regenerative air dryer can drop it by 10 to 25 psi. Our leading air preps result in an expected 3 psi drop. If your concern is pressure loss, we have a feeling you haven't tried ours yet. And finally, the best news is we love to rent air preps. We invite everyone to try before they buy. Just give us a call. Your team has a tough job to begin with, and air prep can remove some of their common headaches. Thanks for watching. We'll see you next week.